Good afternoon, everyone. So, if we have started the solution of second order linear homogeneous equations. So, what we do, we go for the operator D, okay. And here D is d by dx, first order derivative with respect to x. Then d square, it's a second order derivative. So, similarly, if you go for the d cube, that will be the third order derivative. D fourth will be the fourth order derivative, okay. And here for this one. So for the first order differential equation, this is the solution. So for the second order differential equation, this one, and the roots of the equation, this. So here, once we have the second order linear differential equation, homogeneous one, okay, we can find the auxiliary equation and characteristic equation by substituting d equals to m, okay. And the roots of this equation, that means the values of m which satisfy this equation, they are known as the characteristic equations. And it's a quadratic equation, so you will have two roots, okay. So if there are three cases, the roots can be real and distinct, the roots can be real and repeated, that means equal, the roots can be complex, okay. Depending on this b square minus 4ac, it's positive, we will have real and distinct roots. It's 0, we will have real and equal roots, repeated roots. And if it's less than 0, we will have the complex roots. Now if you have real and distinct roots here, so the two solution of equation 1. It's a quadratic one, so we are talking about two solutions. So if these are the solutions here, and they are linearly independent in this interval I, then you can say the general solution of y will be C1e or m1x plus C2 times e or m2x. Okay, so we have a theorem for this one. Okay, if y1, y2 are linearly independent solution of one, that is the linear homogeneous equation on any interval I, then you can say the general solution y equals to C1 times y1 and C2 times y2. See here, it's actually done for n number of linearly independent. Okay, you can extend it to, we have done, since we are doing for the second order, I have done y1, y2. If you have the nth order, we can go for y1, y2, yn or linearly independent solution. Then general solution will be, see here, if you have the nth order, okay, y2, and we have up to y1 are linearly independent solutions. Okay, that means we have this is second order, so we have the nth order one. Okay, then the general solution will be y1 plus c1 y1 plus c2 y2. So this can be extended this way up to cn yn. Okay, so here y is e power m1x and this one. Okay, and how you will get to know whether the solutions are linearly independent or not? You can find the Wronskian. So this Wronskian y1, y2, we have 2. So this is what? So normally you can find up to nth one. Okay. So for the Wronskian here, you can say, if you go for y1, y2. So then there we have the determinant y1, y2 here. So you can go for the determinant here. This is the Wronskian. Then we have the first order derivative. Then we have the second order derivative. Okay, since we have n, so we will go for n minus 1 times. Okay, Okay. And if the Wronskian is 0 or it vanishes, then we will say it's linearly dependent. Okay. If the Wronskian, so this is what we used to say. So it gives this y1, y2. The solutions are linearly dependent. Linearly dependent solution. Then if it doesn't vanish in the interval, okay, then it's a linearly independent solution. Okay. So here y1, y2 I was talking. So y1, y2 are linearly dependent if you are able to find some constants alpha 1, alpha 2, for which alpha 1, y1 plus alpha 2, y2 will be 0, then it will be linearly independent. That means you can express this y1 in terms of y2. Okay, so y1 becomes the dependent variable, y2 becomes the independent variable. Okay, this is what it means. Okay, if you have n number of, then it will be this linear combination will go up to n number of times, alpha 1 y1, alpha 2 y2, up to alpha n yn. Okay, just these are for your information. Okay, so now we will do the solutions, or you want to see this as a derivation? This one, see, we have this, if you look at the second case, okay, you have repeated roots, okay, equivalent repeated roots, m equals to m1 n1. Since we are talking about the repeated roots, only the quadratic one we are considering, second order, okay. So as I said, the first one we have done here, see this one. If you have the cubic order and you have instead of 2, you have 3 distinct roots, then there will be one C3, e power n3x. Okay, it goes on like this for the finite number of orders. Since okay, you can extend this one. I'm not doing, but you just have this idea. Now here also, see real and equal roots. So this is the second order differential equation. If you have this third order and your roots are repeated 3 times, then here you see it is m1 f1 and m1. Then here the general solution will be c1x square plus c2x plus c3. Okay. So this is how you can say m1x. Okay. Similarly, you can go up to the 4 times repeated roots, 5 times repeated roots. So here it will be similarly c1x cube plus c2x square plus c3x plus c4 likewise. Okay. See, if you go for this one, if m1 in repeated, see this one d minus m1 square y. So this is how you will be getting equals to 0. So you can write it this way. Equals to 0. And you can consider this d minus m1 y as u. And you can operate on this d minus m1 u equals to 0. You can solve this one. It's a linear equation of first order. So if you want, you can write it. See, this will be like this du by dx minus m1u 0. Okay. So linear equation of first order. So the solution will be u equals to c1 e power m1x. Okay. This will be easy. This m1 will be p of x Q of x is 0, so this will be the solution. Okay. Now u is what? T minus m1 y equals to c1 e m1x. So if you want, you can write it as dy by dx minus m1y. See, again we have the first order differential equation. Okay. So if you want to find, this is again the p. Okay. So e power minus px. So here you see the solution of y will be, if you use c1x plus c2. c1x plus c2 e power m1x. Got it? This is how the second case. Any doubt with this one? So as I said, if you have three cubic one, it will be c1 x square plus c2 x plus c3. Okay, that way we will keep on increasing. Okay. So similarly, you will find the complex one. Okay. And you can also have the combined form if you have the third degree cubic, or you can have two repeated roots, one distinct root, okay, more than one. Then you will combine this one, okay. We are doing for the second order, I'm not saying that. Okay, so let's do this one now. An example. So d square x by d square minus 3 dx by dt plus 2x. Okay, you can find this one. So find the auxiliary equation or characteristic equation or auxiliary equation. So it will be d square second order derivative minus 3d plus 2. So here d will be dx by dt. So the auxiliary equation will be m square minus 3m plus 2, and we will equate it to 0. So what are the roots here?
1 and 2.
1 and 2. 1 and 2. Okay, then the solution, we know this one will be, y will be. See, if you want, you can check the Wronskian also here. Okay, so that you will get to know whether they are linearly independent or not. So here, y1, y2. So here it will be e power x and e power 2x. Okay, so we have e power x, e power 2x, then the derivative e power x. So here 2. So the determinant. What will be it? Is it 0? Three x. So we have e power 3x, which is not equals to 0 anywhere in the interval. So you can say these two solutions. So these two, they are linearly independent. Okay. So the general solution here will be so x I have written this will be in terms of t. Okay, so this is the general solution. Okay. Okay, so do one more. So find the general solution here. So what do you think? And the auxiliary equation and the solution. So what is the solution? To find the auxiliary equation here. The auxiliary equation here will be m squared plus 4m plus 5 equals to 0. So what are the roots of this equation?
Minus 2 plus I, minus 2 minus I.
So then it gets. So now the general solution, y equals to, so here e power minus 2x you can put it. So it's up to you. We have many forms. Okay. And c1 cos x. So I've given you the initial conditions. You can try. So in the initial conditions, you will find the values of the constants. Okay. So what are the values of constants C1 and C2 if you use those conditions?
And C1 1 and C2 minus 1.
Minus 1. C1 1 and C2. So find y dust here. Both the conditions we have to use. So e power minus 2x.
C1 is equals to 1, C2 is equals to 2 now.
C1 1, C2 2. Yes. So after simplification, you should get this one. Now you can substitute and find out the values. Okay, C1 is coming as 1 and C2 is 2. So here you have the required solution. So this is one solution. Cos x plus 2 sin x. Okay, for this value of constant, okay, with the initial conditions, this is one solution, one required solution. With respect to the initial conditions. So do some more examples. Find the solution of differential equation. So this is the second one. Done for the first one.
And for the first one, y equal to e to the power minus x, c1 cos x plus c2 sin x, and c1 equal to 0 and c2 equal to 1.
For the second one.
No, ma'am, for the first one.
But for the first one, I didn't give any boundary conditions. This is only for the second one.
Okay, ma'am, I took the second one's value.
Okay, what are you getting? What is your answer?
And y equal to e to the power minus x, c1 cos x plus c2 sin x.
for the first one, we have m square plus 2m plus 2 equals to 0. So what is the solution?
-1 plus minus I.
Minus 1 plus minus I. So the solution y will be e power minus 6. C1 cos x plus C2 sin x. So this is the general solution.
Yes, ma'am.
Okay. Now for the second one.
Ma'am, second one,
So what is the solution here? This is the auxiliary equation.
e powered minus 2x into sin x.
E power minus 2x. So what is the, okay, you tell me the roots of this equation first. M value.
Minus 2 plus minus 3i.
Okay. So now the general solution is e power minus 2x, a cos 3x plus b sin 3x. Okay. Now after substituting the initial condition, what you are getting? The values of a and b. How much you are getting? A is
0,
and b is
1.
1.
But, sorry, 1 by 1
1
by
by
3.
3.
1
So
by
now
3.
you can substitute here the required solution. A is 0. So here 0 and b is 1 by 3. So you can make it 1 by 3 sin 3x. This is the solution. Okay. So I think you can do it. Okay. Now should I do one more? So this is the second order linear homogeneous equation. Now we will move on to the non-homogeneous equations. So non-homogeneous linear equations with constant coefficients. Okay. So here normally since the linear equation we use the form this way. Okay. So non-homogeneous. So we did that for the linear second order differential equations with constant coefficients. Okay, homogeneous one. Now we will look at the non-homogeneous one. Okay, non-homogeneous linear equations with constant coefficients, and we are doing it for the second order. So normally we actually write L of y equals to f of x. Okay, So this stands for the linear. Okay, here we are restricting up to second one. Okay, but you can go up to cubic at least. You can solve this one. So linear, homogeneous differential equations. Okay, now we will go for the non-linear, not the non-linear, non-homogeneous. So here we have the homogeneous one. So non-homogeneous, non-homogeneous, linear differential equations. So for the non-homogeneous one, we will be writing Ly. There it is Ly equals to 0. Linear equation is 0. Not fx, here it is 0, this side, right? And this is 0. So you can see the examples here. You see this one, and this is L of y, function of y, and this side, right hand side, is 0. So when we go for the non-homogeneous equation, we have some functions of x. Okay, of this form actually we will be considering. So it's the linear homogeneous differential equation and fx. In the right hand side we have fx, it's a function of x, or it can be constant also. Then it will be non-homogeneous. Okay, if the right hand side is a function of x, then it becomes the non-homogeneous linear equation of order 2. Okay, so here we will restrict ourselves up to order 2. Okay. Now the general solution, how it will be represented. Okay, the general solution of this non-homogeneous equation is represented as the sum of some particular solution of the equation and general solution. Okay, general solution you know how to find. Okay, so here the general solution. The general solution of the non-homogeneous will be given as the sum. Okay, or is represented as the sum of some particular solution. YP and the general solution. General solution of the corresponding linear homogeneous equation. Okay, and the general solution of corresponding linear homogeneous equations. That is L of y equals to 0. Okay. So here, so what you can see, y will be y of p plus y of c. Okay, so y, or you can also say pi, the particular integral. Okay, so particular solution is also known as the particular integral plus the general solution. Okay, that way also you can see. So just remember this yp stands for the particular solution and yc stands for the general solution of the corresponding linear homogeneous equations. Okay, so here we can see how we will find. Okay. So yc is known as the complementary function here. So this is the complementary function. And I was talking about the particular integral. So this is particular integral. So this is P I, and this is complemented function. Okay. So here you can see Pi plus Cf. Okay. So this may also be represented. Okay. So this D we are using mostly to find this particular integral, the operator method we used to say. Okay. And for the constant coefficients. Okay. So let me give you some results. So this L of y equals to fx. We also write this f of d. It's a function of d, right? Equals to f of x. This form we used to write. Okay. So f of d you can say here, since we are considering the second order, okay, you can also say here d2, okay, plus p1d plus any constant p2 kind of. And normally if you go for the nth one, it will be dn plus p1 dn minus 1. So it is this way. Okay. Let's first do for the second order. Then we will go for the higher orders. You can simply extend the ideas. Okay. Now some important results of the symbolic operations. Okay, which okay, some important results here. Okay. So here FD, some working rules you can see. The derivation is also there. I'm not going to do that. Okay. If you want to only for only one, I will do. So here f of t x. Okay, this is t. And suppose this y is the exponential function e power ax. So simply without solving, we will do this one. We simply replace d by a and we will get our result. Okay. So this is the first one. Now the second one. And we have many results. So let me give you this. Now suppose then we have this result. Okay. V of x. It's the product. Okay. So then what you have to do? It will be this exponential. You can take it out. Then f of d plus a. Okay. And it will operate on this v of x. Okay. Now the third rule. Okay. In the third rule, it is for the sine and cosine. Okay. And if you have d square, we can use. Otherwise, you have to do in a normal way. Okay. For both sine ax plus b, cos ax plus b, or cos ax plus b. So this will work for both. Okay. Let me write 1. Sine ax plus b. Then this d square you can replace it by minus a square. F of minus a square. Okay. Or what we do, we simply replace the d square terms and the rest of if you have d cube, we used to make it d square into d, and d square is replaced by minus a square. Okay. And the same is also true for cosine. Okay. That is f of d square cos ax plus b cos ax plus b. Okay. So the first one we can do. Okay, the first one I'm showing you how to do this one. Okay. So these working rules, remember, I'm going to give you some more also. Few more. Okay, but these are the major we are going to use. Okay. See the first one. The proof for the first one only I will do it. So I was talking about the second order. It will actually work for the nth order. Okay. So here dn. Let me write it for. Here the constant and here e power x. Okay. So now you see what will happen here. If you operate n times, only you will be getting a, right? A power n. Derivative of e power x. Okay, first you will derivative, you will get a times e power x. Then second time you differentiate, you will be getting a square. Not it. If you differentiate it n times, you will be getting a power n. Okay, n times the. Similarly here p1 a power n minus 1 and it goes up. Okay, and the last one remains same and we have e power x. But it is a simple one, and this is nothing but the f of a. Okay. So this one I did for the nth one. Okay, you can do it similarly for the second order. Similarly, the others also. Simple proofs. Okay. So and here there is if you have 1 by f of d, like 1 by d square plus d plus 3, then this one is 1 by d is known as the inverse operator. Okay. You can term it as the integration. If you have 1 by d, then you can make it as integration. If you have 1 by d square, you can make it 2 times integration. Okay. Okay. So here, the inverse operator, 1 by d is the inverse operator. I didn't do the proof of others. So here, if you have 1 by d, this one is known as the inverse operator. Sometimes we will deal with, many times actually, we are going to deal with it. 1 by d. Okay. So if you say 1 by d f of x, this is actually the inverse operator of the differentiation is the integration. So it will be the actually integral operator. What is fx dx? So here, and if you have 1 by d square, 2 times you have to differentiate. So 1 by d into 1 by d fx. So first you see 1 by d, this will be the integral of fx dx, and if you go, this will be again the integral. But if this is how you do. Now some more value. These are mostly we are going to use for the particular integral, because you see if you already know how to find the general solution of the linear homogeneous equations. That complementary function part we already know. Simply we will find the auxiliary equation and we will put it to the 0, and the roots of the auxiliary equation. Correspondingly, we will find the general solution. That will be known as the complementary function. Only for the particular integral, we are going to use this part. Okay. Okay, some more I'm giving you. So one more theorem. Okay. So it's related to the inverse operator. If A is any constant, then E for Ax. Okay. So what it will be? It will be E for Ax and we divide it by f of A. Because in the integration, we will have a, okay. And here the only thing we will make sure that is f of A not equals to 0, so that it will be well defined. Okay. So this is the thing. Okay. So now we will do one example. You see how we are using this one. Okay. D square minus 2d plus 1 y equals to e power minus 6. Okay. This is our example. See. So for the general solution, we find the general solution. Okay. Or we will find the solution. So solution will be y complementary function stands for c, then y particular integral. Yp is particular integral. Okay. So for y complementary function, what we consider the corresponding auxiliary equation is m square minus 2m plus 1 equals to 0. Now the roots of the equation will be 1. Okay. So here the y complementary function will be, we already know if it is 1, it will be c1x. If it is repeated and real, c2, and here e power x. So this will be the complementary function every time. Okay. So this is how you find the auxiliary equation of the corresponding linear homogeneous equation. Okay. And find the solution for that. That will be the complementary function. Okay. Now for the particular integral. Okay. So for the particular integral, you see, this is what we have, d square minus 2d plus 1. So here y square minus 2d plus 1 y equals to e power minus x. So here ypi will be 1 by, this one is d square. D square minus 2d plus 1, and here we have e power minus x. But now we will use the formula here, you see. If you have f of a, e power ax, okay, but here we have, you see, the reciprocal 1 by d square minus 2d plus 1. Now if reciprocal is here, it will be e power ax by f of a, only f of a not equals to 0. A is minus 1. If you substitute here, minus 1 square is 1, then minus 2. Minus 1 is plus 2, so 5. So you see f of here, this is not equals to 0. If you substitute, then simply it will be e power minus x. And d, we will replace it by minus 1 square. Minus 2, minus 1 plus 1. So 1 plus 2 plus 1, so e power minus 6 by 4. Got it? So this is your particular integral.
Please repeat that part.
Here you see, this is what I have done. Okay, this is in the inverse mode. Okay, if you have the directly multiplied mode, you can use this one. But here we have 1 by f of t. So for 1 by f of t e power ax, this is e power ax by f of a. That is the solution. Here. So simply we will put this one. We will what we have substituted here. So here d equals to minus 1. Okay, simply. Okay. This makes sure that this, if the only time we cannot substitute this when the denominator is equals to 0. D equals to minus 1, if the denominator goes to 0, then we cannot use this formula. Otherwise, you can use this formula. Got it? It's very simple. Okay. Now the solution here, the general solution, you see. The general solution y is y complementary function plus y particular integral. Okay. So now the complementary function c1x plus c2, c1x plus c2, and here e power x. And the particular integral is this one, e power minus x by 4. So this is the solution, general solution of this question. Okay. Okay. Now there is one more for the product rule also. If you have the inverse operator, okay, so let me give you that formula also. This is the one I have used. And this you have to make sure the denominator term is non-zero. If it's zero, then it's not defined. Got it? Now we will come to, we have another theorem. So that one, when we have e power x, okay, when inverse operator for any constant a, 1 by f of d. And here we have e of ax into vx. The product, okay, with the exponential, then what we will consider, we will take this one too. That means our operator, and this operator will be f of d plus a. Okay, and vx. Vx is a algebraic form. Okay, v of x means the function of x. Mostly it is in the algebraic form. Okay. Now f of d plus a. Okay, then you have to look at it. The inverse operator you can do with respect to the integrals. Okay, but the operator is already operated with e power x. Since we have already taken it to this side, it will only operate on v of x. Okay. So let's see one example, then you will understand. So find the particular integral. So we have already done the complementary function part, so I'm only asking here the particular integral. D square plus 2 so d square plus 2 y x square e power 3x. Okay. So this is what? Okay. Now for the particular integral, since we are finding the particular integral, so this will be 1 by t square plus 2 e power 3x into x square. See, this is what the formula, e power ax vx form. Okay. So you see, you have to first you check. Okay, if you substitute d, it is not going to be 0. Okay. No, it's 3, it's non-zero. Okay. So now if you consider this one, okay, you can take this to this side, and what happens here? D will be replaced by d plus a. So this will be d plus a. A is 3, 3 square plus 2. Okay, and here we have x square. Got it? Now you see, you have to look at, do this. D square plus 6d plus 9 plus 2, and here x square. Okay, got it? So here we have 11. Now how we will use the inverse operator here. D square plus 6d plus 11 and x square here. So we will take it to this side. Okay, what we will do is we will take common 11. Okay, so whenever you have these things, you take common 11 and you are left with 1 plus 6d plus d square by 11. So why I'm doing this, you see. Now what you can do, you can go for the binomial expansion of this one. Okay, you see, e power 3x by 11. Now 1 plus, let me write it, d square plus 6d by 11. So you can expand this one, then you can operate on this one. Okay. I'll write d square plus 6d. So if you look at the expansion here, 1 plus d square plus 6d by 11. Okay. Now the next term will be, sorry, this will be minus. Okay, it will be an alternative series. Okay, so here it is minus. Then the next term will be d square plus 6d square. 1, it is the, see, if you, it is actually, we are making it, it is 1 plus x power minus 1. We will make it 1 minus, because binomial expansion we will only do for 1 minus x form. So how it is to? So it will be 1 minus x plus x square. Okay, it's like that. Okay, because we have this minus. If you make it 1 minus x, it will be plus. Okay. So here this is 1. So the next divided by 11 square, then minus, it goes on. But we have only x square. Okay. So you see, first time if you differentiate x square, you will be getting x. Second time you will be getting 1, and the third time it becomes 0. So we will consider only the d square terms. Okay. So here, let me write. So first one, if you multiply, it will be x square. Next term, d square. Let me write 1 by 11. Then d square, if you operate it, it will be 2x. Then again d operates, it gives you 2. 6d, 6, and d operate 2x. So plus 12x. Okay. Now here you see the terms will be d power 4, then 6d square, and one more term will be d cube. So only 6d square term we will take care of, other terms will be 0. So 6d square will be 2, 6 into 2. Okay. And other terms are 0. Okay. So here we have, so it's 100, 1 to 1. 11 square is 121. Okay. So I think this is the, so you have the answer. Okay. I didn't write the DQ terms because they will be 0. Okay. So here, e power 3x by 11. So I have x square minus, so let me consider the x term, minus 12x by 11, then minus 2 by 11, plus here 6 into 2, it's 12 by 121. Okay. So further you can take 11 to that side, you got 3x by 121. So we have x square, 11x square minus 12x, and here it will be minus 22 plus 12. So here minus 10. I think this is the answer. It is 121. Okay, I took only 11 there. So here we will have, I think, how much? Minus 22 plus 12, it is minus 15. Or I missed something. You check the calculation, okay. I think it's 10 by 11. Check the calculation. Are you getting this
Yes, ma'am.
much?
10 by 11.
Just check the calculation, okay. Okay, it's already time. Let me write down 1. Okay. So you have to do these formulas. You have to combine like you use all the formulas. Okay, reduce it, reuse it, replace it. Okay, all the things. Okay, the more you do, it's only looks. Okay, once you do 3-4 problems, everything will be clear. Okay. So here some more formulas are also there. Okay. We will discuss tomorrow. Okay.
Excuse me, ma'am. Ma'am, will you please explain from the binomial expansion step in this question?
This one, here I did the binomial expansion. Okay,
Yes, ma'am.
this
From this, will you please explain again?
binomial expansion. Okay. So here, this one, see, whenever, normally whenever this is a form, we use binomial expansion. Exponential you have and the algebraic function. You take it to this side. Okay, once you take it, d will be replaced by d plus 3. See, this formula is already proved. I only did one formula. Rest of the things, if you want, you can do it yourself also. Okay, because exponential, so d will be replaced by d plus 3 by this formula. Okay, and there is also like proof is there. Okay, the simple proofs are there. Now d plus 3 square, you open it, you see. So how you will operate? It's the inverse operator. So you only know we can do with 1 by d is there, then we will do the integral. We don't know how to do others. Okay. So whenever you have these things in the denominator, the only thing is we can use is the binomial expansion. So if it is of the form 1 minus x or 1 plus x power minus 1, then you can do. Okay. So we will take common 11 and now we have 1 plus this term will be x kind of thing. Okay. So 1 plus x and here minus 1. It is actually for 1 minus x, so minus of this one. So there will be alternating series here. So this here we have done 1 minus x this way. Normally the binomial expansion this way, isn't it? 1 plus x here you have, so we will make it 1 minus x. So this will be alternating series. Okay, the sign will alternate. So 1 and this will be 1 minus x plus x square minus x cube. This is what. So x is this much, okay? X is this much. Is it okay now?
And ma'am, in the next steps, how you wrote 0?
See, d is the second order derivative, you know. Got it?
Yes, yes,
And
ma'am.
the d cube will be the third order derivative, but here we have the x squared term. For the third order derivative, it will be 0, isn't it?
Okay, ma'am. Got it, ma'am.
That's why I didn't mention the higher terms. Okay, only up to d2. D cube will give it 0. Other terms will give you the higher powers only.
Okay, ma'am.
Got it?
Got it.
Okay. You just practice and it will be clear. Okay. Even you can do up to we did it for the second order. You can also go for third order, fourth order. Okay. So if you want many, you can practice and a few more, 2-3 more formulas are there. We will do. It's very simple. Okay. Simply we will be using the formulas. Okay. Okay, then I'm ending the class. It's already time. Okay. You can do the questions if you want. Okay. And it's the exercise 5.2. Exercise 5.2. I'm writing it here. Okay. Few more formulas are there. Okay. And we will do it next class. Okay. Okay, I'm ending the class.
Thank you, ma'am.
Thank you, ma'am.